Hi, welcome once more to Mr. Max. In this lesson, we are going to revise from Northwest Province September 2020 Euclidean Geometry questions. Okay, Northwest is September 2020 Euclidean Geometry question. That is question number 8, 9 and 10. So let's start. Question number 8. Look at that question. In the diagram, O is the center of the circle with the radius OC. So O is the center of the circle. So this is a circle with the center O. Okay, and radius OC. And OC, which line is OC? This line. This is the radius of the circle OC. Okay. Now ABCD is a cyclic quadrilateral. ABCD is a cyclic. You can see that one is all those 4 points are on the circumference of the circle ABCD. Okay. Now N is another point on the circle says that ON is parallel to BC. So it is given that this line ON is parallel to BC. These two lines are parallel. Okay. Then chord DN is drawn. OE bisect chord BC at E. Okay, that is a very important clue, guys. Chord DN. Which one is DN? DN is this one. Okay, so chord DN is drawn. Oh, okay, sorry. OE bisect chord BC. OE bisect chord BC. Bisect means they are saying that these two lines are equally dividing. That is bisect. Okay, this OE bisect line BC. So it means that this point E is the midpoint, or BE is equal to EC. Okay, that's an important clue. GC is a tangent to the circle at C. So there is a tangent GC. Then ON and GC produced to meet at F. Okay, this point is F. OC is equal to 20 degree, this angle is 20 degree and this angle is 150 degrees. So these are the given information. Then based on this one we have to answer the remaining question. Okay, so what is the first question? 8.1.1. What is that question? Calculate O1. You have to find what is angle O1. So which one is O1? I didn't mark that one. This is O1 and this is O2. So you have to find this angle O1. So how can you find that one? Pause the video and try by yourself. Okay, so now look at this one. These two lines are parallel. Okay, and is it not this OC a transversal for parallel line? There are two lines like this. These two lines are parallel. Okay, and there is a line like this. This is our point O and this is our point C, and it is given that this C2, this is 20 degrees. So what about this O1? O1 is also 20 degree. Can you see that this angle is, there is a line BC. Those who are following that is at BCOF. Okay, can you see that this 20, if this one is 20, this is also 20. Can you say what is the reason? These two lines are parallel. So it means that since these two lines are parallel, these two angles are alternative angles. Am I right? So angle O1 is equal to 20 degrees. What is the reason? Alternative angles. Then you have to say which two lines are parallel. Okay, ON is parallel, or OF. ON is parallel to BC. That is why O1 is equal to 20. Okay, now next question, 8.1.2. What is that question? 8.1.2. Angle D1. Angle D1. Where is angle D1? This angle. What is this angle? Angle D1. So that is also simple question. Look at this angle O1. O1 is coming from these 2 points N and C. Angle at the center. Am I right? Okay. From the points N and C, that angle is formed O1, 20 degree. So from the same point N and C, can you see this angle D1? So that is angle at the circumference. So what is the relation connecting angle at the center and angle at the circumference? You studied the theorem. Angle at the center is 2 times angle at the circumference. Okay. So here, if the center angle is 20 degree, what is this one? That is 10 degrees. Am I right? Okay. So like this, guys, this is the angle at the center, and here it is 20 degree. So from the same point, this one is angle at the circumference. This is the center. Okay. And this one is D. So what is this one? half of that one, that is 10 degree. Okay, so angle D1 is equal to 10 degrees. What is the reason? Angle at the center is equal to 2 times angle at the circumference. Okay, so that is 8.1.2. Now let's move to the next question, 8.1.3. 8.1.3. What is that question? Angle C2. So angle C2, where is angle C2? This angle. You have to find that angle, angle C2. So how can you find that angle, guys? Here, pause the video and try by yourself first. Okay. Now, assume that this is a circle. Okay, and it is given that ABCD is a cyclic quadrilateral. Am I right, guys? It is given that this A, B, C, D is a cyclic quadrilateral. Okay, and there is a line. This angle is C3, that is 20 degrees. Okay, and this is what we want to find, C2. Okay, now what is this angle? It is 150 degrees. So you know that opposite angles of a cyclic quadrilateral is supposed to be 180 supplementary. Am I right? Okay, so when you add this 150 plus 20 plus this C2, it is 180. Am I right? Okay, so opposite angles of a cyclic quadrilateral is 180. So that is what we are applying, going to apply. So angle A plus angle C2 plus that 20 degrees. Okay, and that is 180 degree. This angle A and this total angle, it is 100. When you add this one and this total angle C2 and C3, you are supposed to get a 180 degree. Okay, that is A plus C2 plus 20 is equal to 180, because this C3 we already got, or it is given in the question that it is 20. That is why here we wrote a 20. Okay, so what is the reason? Opposite angles of a cyclic quadrilateral. Okay, so from here, what is A? 150 plus C2 plus 20 degree is equal to 100. Now just a calculation, that's all. What is C2? Take everything to that side. So it is 180, 150 on the other side, minus 150, 20 on the other side, it is minus 20 degree. So take your calculator, find the answer. 170, 180 minus 170, 10 degrees. So it means that this angle C2 is 10 degrees. Okay, so that is question number 8.1.3. now let's move to the next question, 8.1.4. Question number 8.1.4. What is that question? Angle D2. You have to find angle D2. Where is angle D2? This is angle D2, guys. You have to find that angle. How can you find that angle? Angle D2. So for that, D2 is that angle. Okay, now look at this one, guys. Here you have to try yourself first. Okay, then only watch this one. Okay, so look at this one. This, from this point to this C, is it not that the radius of the circle? Is it not that the radius of the circle OC? OC is the radius of the circle. Am I right? Okay, and now look at this line. What is the name of that line? Is a tangent. Am I right? Okay, so this one is the radius and this one is a tangent. So what is this angle? Radius is perpendicular to tangent. Am I right? So the total angle, that means C3 plus C4, is it not that angle? The angle between this line, radius, and this tangent, that is C3 and C4. So C3 plus C4 is 90 degree. Am I right, guys? So what is the reason? Okay, so angle C3 plus angle C4 is equal to 90 degrees. What is the reason? Radius is perpendicular to tangent, or tangent is perpendicular to radius. Okay, so now C3 we already know that it is 20 degrees. So how can I find a C4? Is 90 minus C3 is what? 20 degrees. So plus C4 is equal to 90 degrees. So what is C4 now? It is 90 minus 20 degrees. So C4 is equal to 70 degrees. So it means that angle C4, this one is 70 degrees. Do you agree, guys? Okay, so that angle C4 is 70 degrees. But what is our question? We have to find angle D2. Okay, so for that what you have to do is look at this tangent. Can you see this tangent? Which line is that? BC. BC is a tangent, am I right? Okay, so that C4 is the angle between the tangent, not what I am saying. BC is what? A chord. Okay, look at the chord BC. This is BC is a chord, not a tangent. Okay, this one is a tangent, sorry for that. Okay, so this GCF, that is a tangent, and this one is a chord. BC is a chord. Is it not this C4 is an angle between tangent and the chord? This tangent and this chord, that's 70. Okay, so let me draw it here. There is a circle like this. Okay, and this one is a tangent. Okay, and now there is a chord like this. This is our G, C and F. Okay, this is a tangent and this is our chord BC. So what is this C4? This is C4. What is that angle? 70 degrees. So what you have to check is from these 2 points on the chord, at the end point of the chord, okay, where that angle is leading to the circumference. Can you see from the point B and C? Can you see this line is going to D2? So if this one is 70, what is this one? D. This is D2. What is that one? That is also 70 degree. Can you say what is the reason? Tan chord theorem. The angle between the tangent and the chord is equal to the opposite in the angle. Am I right? Okay, so now we can write therefore angle D2 is equal to 70 degrees. What is the reason? Tan chord theorem. Because of the tan chord theorem, that angle is also, this is the chord from that point B and C. This is the chord, am I right? This is the tangent, this is the chord. So the angle between the tangent and the chord is 70. So this chord B and C, where it is leading to the circumference? D2. So if that one is 70, this is also 70. So what is this angle? It is 70 degrees. So now we know that D2 is also 70. Okay, so that is question number 8.1.4. Now let's move to the next question. 8 point what? Let's move to the next question. Question number 8.2. So guys, this is a video lesson. That is why I'm erasing it fast. Okay, so you have option that you can pause the video. Am I right? Okay, so if in case if you didn't write this one, maybe you are listening at that time. Okay, so in case if you didn't write this one, you have to pause the video and write fast. Okay, then only you continue that one. You don't want to continue without writing that, copying that one in your notebook. Okay, so that is why I'm erasing that one without waiting for you to write. Okay, because we have to, otherwise the GB, the size of this video file is too big. It's one file itself is 15 GB, 20 GB like that. Okay, so that's why I'm erasing it faster. What you can do is you just pause the video, write it, or you can backwards. Okay, you can now move a little bit back and write that one. Okay, so anyway, let's move to the next question. Question number 8.2. What is that question? It is given that OF is equal to root 3y. So which one is OF? From here, from this line, O to F. What is the length of that one? Root 3y. Am I right? From O to F. Don't forget that. Okay. Then EC is equal to 2x. Where is EC? This line. This line is 2x. So the length of that line EC is 2x. Okay. Now the area of OECF. What is that one? Area of, excuse me, area of OEC what? OECF. Okay, so which one is that? OECF. The area of this one. What is the area of that one? What is the area of that one? 3 by 4 y square. 3 by 4 y square minus x square. Area of that one is 3 by 4 y square minus x square. Okay. So now what you have to find? Determine the length of OE. You have to find the length of this OE in terms of x and y. You have to find the length of this OE in terms of x and y. So what is given? The area of that OECF. Can you identify what is the shape of that OECF? Can you see these two lines are parallel? This line parallel. That means the shape is like this. This is our OE, this is OEC, and this is the line F. O, this is O, and what is this one? E, and this is the point C. Can you say, and also it is given in the question that these two lines are parallel. That means one pair of parallel lines. What is the name of that shape? It's a trapezium. Am I right? Okay. So in the case of a trapezium, how can you find the area? What is the area formula of a trapezium? You have to add the, which two lines are parallel, you have to add that one, multiply with this height OE. Okay. So here what is that one? Area of this trapezium, how can you write? 1 over 2 into, you have to know that formula. Okay. OF, this is the formula that you have to apply to find the area of a trapezium. Okay. OF plus EC, that two parallel lines, times this perpendicular height OE. And it is given in the question that that one is 3 over 4 y square minus x square. You understand, guys? Okay. So half into OF plus EC times OE, that is given as this one. Okay. Now what is this OF? OF is given as root 3y. And what is EC? EC is given in the question as 2x. So we can substitute that values. So it is half into OF is root 3y. It is given like that in the question. Plus EC. EC is 2x. It is given. Okay. And OE. That is what we want to find. We want to find the length of OE in terms of x and y. And that is equal to 3 over 4 y square minus x square. Okay. So that D is not a part of this one. D is that point. This is the point D. Okay. Now what we can do, guys, here. What we can do here, it is 3 by 2. Are we stuck here? No, we are not stuck. Okay, so what we have to do now, we have to find OE. Am I right? All of these are multiplication. Okay, so what I'm going to do is let me expand this one. Half into root 3y, half into 2x, like that. Expand that bracket. Okay. So half into root 1 into root 3 is root 3y, 2 denominator divided by 2. Okay. Plus then 2x, half into 2x, like this, half into 2x. These 2 and 2 cancel. So what is remaining? 1 times x, that is x. Are you with me? Okay. So that one is root 3 by 2, root 3 by 2y plus x. Okay. Times OE. This is multiplication. OE is equal to, now here root 3 by 4 y square minus x square. Can you see root 3 y by 2 plus x? Okay, so that one, how I am going to write is this one. Okay, I can see a perfect square, difference of two squares there. This root 3 by 4, I'm going to write it like this. Root 3, I mean 3y square by 4, I'm going to write like this. 3 root 3 by 2 y the whole square minus x square. The same thing, I wrote it like this. How? Root 3 square is 3, 2 square is 4, y square is y square. You can see, then x square, there is no difference, the same thing. Okay, so this one I can write it how? Root 3 by 2 y the whole square minus x square. Are you with me? Okay, is it not that difference of two squares? Okay, so if it is like this, a square minus b square, how can write a minus b into a plus b? Similarly, we can write this one. Okay, so now we can go to the next step. We have to find OE. Okay, so what is OE now? Therefore, OE is equal to, here it is multiplication. So if I want to take this one to the other side, it is division. That means divided by this or the whole of this thing. That is root 3 by 2 y plus x. Okay, this is y. Yeah? This one is y. Okay, now this side, this one, I can expand like this, a minus b into a plus b. So how can I, this is a and this one is b. Okay, so it is a minus b, that is root 3 by 2y minus b x into a plus b. This root 3 by 2y is a, so it is root 3 by 2y plus b, that is this one. A squared minus b squared is a minus b into a plus b. Okay, so now can you see these two quantities are the same thing, so we can cancel that too. So what is OE? OE is equal to only root 3 by 2y minus x. Did you get the answer in terms of x and y? Yes. So that is the question. Determine the length of OE in terms of x and y, and that is the length of OE in terms of x and y. Okay, so that is question number 8. Now let's move to the next question, question number 9. Let's move to the next question, question number 9, 9.1. In the diagram, chords AB, BC and AC are drawn in the circle with the center O. So there are some chords AB, BC and AC are drawn, and DC is a tangent to the circle. This one is a tangent to the circle at C, the point C. What do you want to prove? Prove the theorem which states that angle ACD is equal to angle ABC. Which two angles you have to prove? Angle ACD, that means this angle, and ABC, that is this angle. You have to prove that two angles are equal. That is the question. Okay. So how can we prove this one? This is a theorem. What is the name of this theorem? You remember this one? Tan chord theorem. The angle between the tangent and the chord is equal to the opposite angle. Okay. So here we have to prove that two angles are equal. So to prove that this theorem, we have to construct something first. Okay. First we have to construct something. What we want to construct it? I'm going to draw a straight line passing through the diameter. That means passing through the center. Okay, and that's the diameter. Okay, so and let me call this point as F, and I'm going to join these B and C like this. Okay, so what I drawn, that is my construction. Okay, so actually that this line, this diameter CF and FB was not there. Okay, so we constructed that one. That is why I draw with a dotted line. And also if you construct something to prove a theorem, you have to write the construction, what you constructed. Okay, so what is the construction we done? Construction, draw FC the diameter, draw FC the diameter, or draw the diameter FC. Okay, join F and F and B. Okay, draw FC, the diameter, and join F and C. Okay, or draw the diameter FC, join F and B. Okay, whatever may be. So now we have to start the proof. Okay, so what is the proof? How can we prove this one? Okay, we have to prove tan chord theorem. That is the question. Okay, so now let me call this angle as, this is, let me say this is C1 and this one as C2. This angle is C2. Okay, and let's say this is B1 and this angle as B2. Okay, now okay, what about C1 plus C2, guys? What about C1 plus C2? C1 plus C2, when you add the, what is this one? The diameter. Or this one, this is the center, so this is the radius. Am I right? Okay, that line is the radius and this one is a tangent. So you studied that radius is perpendicular to tangent. Am I right? I'm talking like this. This is the center. Okay, and this is OC, or dotted line. Okay, this is the point C and there is a tangent like this. So this total angle is C1 plus C2. You know that radius is perpendicular to tangent. Am I right? Okay, so C1, when you add these two angles, okay, when you add these two angles, you are supposed to get 90 degrees because radius is perpendicular to tangent. Okay, so that is what I am going to write. C1, angle C1 plus angle C2 is equal to 90 degrees. What is the reason? Radius is perpendicular to tangent. Okay, now also look at this line FC. Is that FC is the diameter? Yes, FC is the diameter. Okay, so from that diameter, can you see this angle is formed, that is B1 plus B2, the total angle from the points F and C, that B1 plus B2 angle is formed. Okay, can you say what is that angle? You studied like this angle in a semicircle, for example this one. Okay, so what is this angle in a semicircle? It is 90 degree. So it means that this B1 plus B2, combine that angle B, that is the angle formed on the circumference. So it is B1 plus angle B1 plus angle B2. What is that one? That is also 90 degree. What is the reason? Angle in a semicircle. Am I right? Okay, okay, I can write it there, angle in a semicircle. Okay, so that is B1 plus B2. Okay, now look at this one, angle C1 plus C2 90, angle B1 plus B2 is also 90. So what is the meaning of that? This C1 plus C2 and B1 plus B2 are equal. Okay, because the right side we got is equal, so it means that the left side are also equal. So it implies that angle C1 plus C2 is equal to angle B1 plus B2. That two angles are equal. Okay, but now look at this one, guys. Here look at these 2 points A and F. Okay, from that point A and F, can you see this angle C2 is formed? From that point A and F, can you see this angle C2 is formed? Okay, and from the same point A and F, can you see this angle B2 is formed? Can you see that? Okay, this is a circle and there is a point F here and there is a point A here. So from the point A and F, this angle C2 is formed. Okay, from the same point A and F, this angle B2 is formed. So it means that this C2 and B2 are equal. Can you say what is the reason? Because of the angle in the same segment. Am I right? Okay, so but angle B2 is equal to angle C2. Okay, what is the reason? Angles in the same segment. You studied a theorem like that, angles in the same segment are equal. Okay, so we got that two angles are equal. Now look at this one. Let me call this as equation number 1. Okay, so now therefore equation number 1 implies, okay, so now here we are saying that B2 and C2 are same quantity. Look at this one, this is C2 and this is B2. So these two are in this equation, this B2, this C2 and this B2 are same thing. So you can cancel that one, this C2 and B2, because it's the same thing. Am I right? Okay. For example, x plus 2 is equal to let's say y plus 2. Okay, so I can cancel without thinking anything. I can cancel these 2 and 2, guys, because if that 2 are same, sign also must be same, plus 2 plus 2. I can cancel like this. Do you know why? Because in case if without cancelling this one, if I didn't cancel this one, okay, assume that I didn't cancel this one, this is 2 and this one 2 also there. Okay, so if I take this plus 2 to this side, so what is going to happen? This plus 2 on this side, it is minus 2 is equal to y. Can you see now? I can cancel this plus 2 and minus 2. So there is no need to write that step. If it is same quantity on both sides, so you can cancel that. Okay. So here we are saying that this C2 and B2 are the same quantity. Okay. So you can cancel that one. So what is now? What is our equation? Angle C1 is equal to angle B1. Okay, is it not that what we want to prove? C1 is the same as ACD. Okay, so this angle C1 is the same as angle ACD. And what is B1? B1 is this angle ABC. Okay, B1 is the same as angle ABC. Is it not that what we want to prove? Okay, so this is the tan chord theorem. This is how you want to prove the tan chord theorem. Okay, so you have to study this one as it is. Okay, and when you have a question like this to prove the theorem, tan chord theorem, you have to write as it is. Okay, so anyway, that is question number 9.1. Now let's move to the next question, 9.2. Okay, let's move to the next question, question number 9.2. In the diagram below, the center of the circle is O with the diameter KL. So this is the center of the circle and this KL is the diameter. M and P is a tangent to the circle at the point N. This M and P is a tangent. Chord Kn and Ln are drawn. R is a point on Kn and ORSP forms a straight line. Okay, ORSP is a straight line. Okay, so look at this one. This point P is outside the circle. Okay, that's a point on the tangent. Okay, OP is equal to 15 units. OP, that means from here to here, the distance is OP is OP. What is that one? 15 units. Don't forget that one. We have to use that one. OP is equal to 15 units. Okay. Now 9.2.1, first question. What is that question? 9.2.1. Give the length of OR if OR is to RP is 2 is to 3. So you have to find the length of OR and what is the ratio given? OR is to RP and it is 2 is to 3. Okay, so which one is OR is to RP? This is the line OR and this from this R to P. Okay, and let me draw that one. This is our point O and this is the point R and this is the point P. There is a point S on the middle. Okay, now OR is to RP is the ratio is 2 is to 3. Okay, and what is the length of this OP? Look at the question. OP, it is given as the actual length. That is not the ratio. The actual length is 15 units. And now what is this question? Calculate the length of this OR. So now the ratio is given. OR, what is the ratio? 2. 2 out of what? What is the total ratio? 2 plus 3, 5. That means the length of OR, the ratio is 2 out of total 5. 2 plus 3. Okay. So how can you find the length of OR now? 2 by 5. OR is 2 and what is the total ratio? O to P, 2 plus 3, 5. Okay, so it is 2 out of 5. And what is the length of OP? It is 15. So how can I find the length of OR? 2 by 5 times the total actual length of OP, that is 15. Okay, so what is that one? This is 3, 2 times 3, 6 units. Okay, so it means that the length of this OR is 6 units. This one is 6 units. Okay, 6 units. Now what is the next question? So in case if the question is to find the length of RP, that question is not there, but in case if you want to find, how can you find? So you have to check RP is, what is the ratio? 3 out of, what is the total total 1 2 plus 3 5 times 15. Total O to P, the actual length is 15. So it is 5 3 times 3 9. So the actual length of RP is 9 units. Okay, so OR is 3. What is the length of OR? 6. This is 6 and this one is 9. Can you see 6 plus 9 is 15? You understand? Okay. Okay, anyway, that is our question, but you don't want to write this one. That is not in our question. You just want to write only up to here. Okay. So that is 9.2.1. Now let's move to the next question, 9.2.2. Question number 9.2.2. What is that question? It is given that Kp square minus Ko square, Kp excuse me, Kp square minus Ko square is equal to 36. Prove that OR is perpendicular to KL. You have to prove that OR is perpendicular to KL. Where is KL? Oh, okay. OR is this one and KL is this one. That means you have to prove that this angle is 90 degrees. That is the question. Okay. You have to prove that that angle is 90 degrees. Okay. So how can we prove that one, guys? Here, look at this triangle. Okay, look at this triangle. I don't know it's a right angle triangle or not now. Okay, that is what we want to prove. Now we don't know is it a right angle triangle or not. Okay, so I'm just checking that one. If this one is 90 degree, okay, so what is KR? How can we apply Pythagoras theorem? In case if that one is a right angle triangle, how can we apply the Pythagoras theorem? KO, where is KO? KP, where is KP? Is there in such a line like that? KP square oh, I made a mistake here, guys. Sorry, this is look at the question. That one is KR. Okay, KR square minus KO square. That's why I confused why it is like that. Okay, so anyway, it is given that KR square minus KO squared is 36. Okay, now in case if that one is a is 90 degree, I don't know, that is a question. Okay, so in case if it is 90 degrees, we can apply Pythagoras theorem there. Am I right? Okay, so how can we apply Pythagoras theorem? Hypotenuse square, that is KR square, is equal to, I'm trying to apply Pythagoras theorem here, the sum of the sides of the other two, sum of the, that is OR square plus KO square. Am I right, guys? Okay, so in case if that one is a right angle triangle, then we can apply the Pythagoras theorem. KR squared is equal to OR square plus KO square. Okay, but here we can't directly substitute the values and say it's 90 degree, because here we are not at this stage, we are not supposed to write it like this. This is wrong, because we can write it like this only if we know that that one is 90 degrees. But here the question is, we have to prove that that one is 90 degrees. You understand? So directly you can't apply like this. We can't say that this one is equal to this one, because we don't know it is 90 degrees or not. We don't know that one is a right angle triangle or not. Okay, so what I'm going to do is I'm going to find from here, look at this one, KR square, let me take this is KR square, let me take this KO square to this side. Okay, so KR square, if I take this positive to this side, it is minus KO square is equal to OR square, only OR square remaining here. Okay, so now what is the answer of kr square minus ko square? It is given that it is 36. Please don't write it now. Is equal to, what is or square? What is or? Or is 6. So it is 6 square. What is 6 square? 36. So you can see that the left hand side and right hand side you are getting the same answer. So now what we can say? Pythagoras theorem existing. Am I right? Okay. So if Pythagoras theorem existing, it means that that one is a right angle triangle, or that angle is 90 degree. You understand? So how can we write this one, guys? Here what I am going to do is, let me write the left. I am not going to write this one first. If I write this one first, then it's wrong. You won't get mark. Okay. So let me write it like this. Left hand side is equal to kr square minus ko square is equal to 36. Then right hand side is equal to, what is the right hand side? Or square is equal to 6 square. So it is 36. It implies that left hand side is equal to right hand side. It implies that KOR, angle KOR is equal to 90 degrees. You understand? Okay. Or what we have to write? KR OR is perpendicular to KL, or it implies that OR is 90 degree, means that two angles are 90 degree, perpendicular. OR is perpendicular to what? KL. Okay. So you can write it like this, guys. Okay. Because don't write this step first. If you write this step first, it's wrong. Okay. Because this step you can write after you prove that this one is 90 degrees. Okay. So that is question number 9.2.2. Now let's move to the next question, question number 9.2.3. What is question number 9.2.3? Prove that ORNL is a cyclic quadrilateral. You have to prove that ORNL is a cyclic quadrilateral. Which one is ORNL? O is here, R is here, N is here, L is here. That means you have to prove that that one is a cyclic quadrilateral. That means there is another circle. Okay, not based on this circle. Okay, you have to prove that this one is a cyclic quadrilateral. ORNL. You understand? That red one is a cyclic quadrilateral. Okay. So how can we prove that one, guys? ORNL is a cyclic quadrilateral. So now we know that this angle is, previous question, this angle O1 is 90 degrees. Okay. So O1 is 90 degree. Now look at this angle. Look at this KL. Is it not the diameter? Okay. So the angle formed from the diameter is supposed to be what? 90 degree angle in a semicircle. This is the diameter. So from that diameter, the angle formed on the circumference is supposed to be 90 degrees. So this angle is 90 degree and this O1 is 90 degree. What is the connection between O1 and that angle N? Is it not an exterior angle? This is a we have to prove that this one is a cyclic quadrilateral. Okay. So this one is an exterior angle, and look at this one, interior opposite. So this one is 90 and interior opposite also 90. So it means that exterior angle is equal to interior opposite angle. So we can say that this one is a cyclic quadrilateral. So now we have to write that one. Okay. So what we can write? Angle O1. Which question is this? 9.2.3. Am I right? 9.2.3. Okay. So angle O1 is equal to 90 degrees. What is the reason? We already proven that one on the previous question. Okay. And angle N is equal to 90 degrees. What is the reason? What is the reason for that? Angle in a semicircle. Angle in a semicircle. Okay. So it implies that angle O1 is equal to angle N. Am I right? Is equal to 90 degrees. Okay. So now we can straightforward write the answer. It implies that, which one is that? ORNL is a cyclic quadrilateral. But the final mark is for the reason. What is the reason you have to write? You have to write that is the exterior angle of a cyclic quadrilateral. So how can you write the reason? Converse of exterior angle of a cyclic quadrilateral. Why we have to say converse of? Because what is the theorem you studied? If it in a cyclic quadrilateral, exterior angle is equal to opposite interior. This is the theorem you studied. In a cyclic quadrilateral, exterior angle is equal to opposite interior. But here what we are saying, since exterior angle is equal to opposite interior angle, this one is a cyclic quadrilateral. That is why here we have to write you must have to write converse, otherwise you will lose 1 mark. Okay. So that is question number 9.2.3. Now let's move to the next question, 9.2.4. Okay, let's move to the next question number 9.2.4. Question number 9.2.4. What is that question? Here M and P, this is like a paragraph. Okay, M and P is translated to the left side of the circle such that M dash falls outside the circle and N dash inside the circle. The point P dash coincide with the point S. What is the meaning of that sentence? Look at this one. This is the line M and P. Am I right? That tangent is called M and P. This tangent M and P. You can see that. Okay. So that M and P. Now they are saying that this M and B, this tangent is shifted to the left side. Okay, this tangent is shifted to the left side, and M dash, the new tangent, this is the tangent M and P, and it is shifted to this side. Okay, and this M, now here it is M dash. This N, now here it is N dash. Okay, and this P, now here it is P dash. Okay, now look at that first condition, such that M dash falls outside of the circle. So this M dash, when it moves to this side, this M dash is coming somewhere here. Okay, M dash is coming, okay, on the left side. It is not moving up. Okay, so let me write on next to that one. Okay, and this is M dash. Now we can see that falls outside the circle. Okay, then N dash inside the circle. This N dash, it is inside the circle. Let me erase this 90 degrees. Okay, so N dash is inside the circle. So this is N dash. Okay, and P dash is P dash is coincide with the S. Am I right? The point P dash coincide with the point S. That means this point S itself is P dash. So it means that that point S is P dash now. Okay, and that is a new tangent, new line. Okay, can you see that this line they are talking about? Which line is that? M dash, N dash, and P dash. Okay, so here we can see that P dash coincide with the S, the same point. S and P dash are the same. This N, that is N, this point is N, and this point moved to the left, that is now it is N dash. Okay, and this point M moved to this one, that is M dash. Do you understand? Okay, now what is our question? Next sentence, the points O, L, S remains fixed as indicated on the original diagram. M and P is parallel to M and, okay, so now look at the next one. M and P is parallel to M dash, N dash, and P dash. So M and P must be parallel to, so it means that these two lines, this line is parallel to this new line. So these two lines are parallel. That's a very important clue. Okay, is it possible? Now the question is like this: is it possible for M dash, N dash, P dash to be the tangent of the tangent to the circle drawn through OLS? So OL, where is LS? Let me draw that circle once more here. Assume that this is that circle. This is our point O, and this is our point L. So this is the line, and this is S or our new tangent. But they are saying that shifted one P dash, and they are saying that this S and P dash are coinciding. Okay, so it means it's the same point. Okay, now this is O1. We already proved that this angle is 90 degree. O1 angle O1 is equal to 90 degree. What is the reason? We already proven that one. Am I right? Okay, so what about O2? Therefore O2 is also 90 degree. What is the reason? Angle on a straight line. Okay, so angle, that one is also 90 degree. Okay, so now look at this one here. Let me draw like this once more, that one. Okay, so if this angle O2 is 90 degree, and for a tangent, they are saying that that tangent is passing through P dash or S. Am I right? Okay, P dash or S. So if this one is passing through this one, if that tangent is a tangent, then it is supposed to be like this, and this angle must be, the angle between this chord and that tangent must be 90 degree. Can you say what is the reason? Because you studied the angle between the tangent and the chord is equal to this one. Okay, so we already know that this angle is 90 degree, then this angle between the tangent and the chord must be 90 degree. Okay, but here they are saying that the new line is passing through P dash. That means this is the new line. This is the new line. Okay, now look at and it's claiming that this one is a tangent or not. Okay, so now look at this angle. Is it 90 degree? If this one wants to be a 90, if this one wants to be a tangent, then this angle is supposed to be 90 degree. Can you see that? Okay, if this one is 90 degree, if this one is a tangent, and if this one is 90, then we can say that 90 and 90. Okay, but if this one wants to be a tangent, the green one wants to be a tangent, then this angle must be 90 degree. Then only we can say that this one is a tangent. But here you can see that it is much less than 90 degree. Am I right? Okay, so we have to express, we have to write that one. Okay, so for that we can write it like this. If M and B dash, okay, M dash N dash P dash. Okay, so this is M dash, N dash is somewhere here. Okay, N dash, and this point itself is P dash. Okay, so if M dash N dash P dash is parallel to M and P, if M dash N dash and P dash is parallel to M N P, okay, then this line, this angle LSM, it implies that angle LSM is less than 90. It implies that that angle, if that one is parallel to this L, that line, do you remember that line, this first one, this M and P? Okay, so if this one is parallel to this one, then angle LSM is less than 90 degrees. Okay, so it implies that, what is the meaning of that? These two angles are not equal. Which one? O2 and angle LSM are not 90 degree. Okay, so it implies that angle O2 is not equal to angle LSM. So if that two are not equal, okay, O2 is 90 degree. Do you remember that figure? Okay, O2 is 90 degree and the other one is less than 90 degrees. So it means that it is not equal. Okay, so it implies that the new line M dash, N dash and P dash is not a tangent, okay, of the new circle, not a tangent. What is the reason? Converse of tan chord theorem is not existing. What is the reason? Converse of tan chord theorem not existing. Am I right? Do you remember tan chord theorem? That one, and the 90 degree and 90 degree, it must be 90 degree 90 degree. Okay, but we are not getting 90 90, so it means that that one is not a tangent. Okay, that is why we have to write converse of tan chord theorem not existing. Okay. Okay. Yeah, it's a tricky one. You have to think, and the way that you are writing, that's also important. We can understand from there it is, if this one is 90 degree, then that is also supposed to be 90 degree if it is a tangent. Since we are not getting that as 90 degree, it means that it's not a tangent. Okay, that's all the concept. Okay, so but how we express that one, how we write that in step by step. Okay. Okay, now let's move to the next question, question number 10. Okay, let's move to the next question, question number 10. Two circles touch each other internally at a B. So there are two circles here. One is a big circle and the small circle. Okay, and that two circles touch at this point B. This is a common touching point of both the circle. Okay, now what is next sentence? O is the center of the bigger circle, lies on the circumference of the smaller circle. So this point O is the center of the big circle, and it is, that point O is a point on the circumference of the small circle also. Okay, FBG is a common tangent. This one FBG, this is F. So FBG is a common tangent and intersect the small circle at D and E respectively. Okay, D and E respectively. This one AHG forms a straight line. Okay, AHG, that one is a straight line. Chord OD, DE, OB of the smaller circle are drawn, and there is a one important clue. AH is to, what is that ratio? AH is to HAG, and the ratio is equal to 1 is to 2. Okay, so AH is to AG. So here you can see from this ratio itself, before we go to the first question, AH is to AG. AH is from here to here, and the ratio is 1. Okay, and AG is from here to here. They are saying that the total ratio is 2. So it means that here also the ratio is 1. Am I right? Then only 1 is to 2. AH 1, AG 1 plus 1, that is 2. Do you understand? So AH is to AG means 1 is to 2, means that AH is 1 and HG is also 1. Then only AH 1, AG, can you see AG, it is 2. So it means that AH up to here it is 1, then to get it 2 as AG, here this HG also supposed to be 1. That means this H is the midpoint of that line AG. We can interpret like that. Okay. Okay, now 10.1, first question. What is that question? 10.1.1. 10.1.1. What is that question? Give reason why B4 is equal to HCB. You have to write the reason why angle B4 is equal to angle HCB. Which two angles are that? B4. There are so many lines here, guys. Don't be confused. This is B4 and HCB. H is here, C is here, B. That means you have to prove, you have to write what is the reason that this angle and this angle are equal. So now what we can say, look at these two lines. Can you see that this line HC and this line GBF, that two lines are parallel? It is given like that. Can you see that these two lines are parallel? Okay, so what about this line? Is it not a transversal, that one? Okay, there are two parallel lines like this. Okay, and there is a, and this one is B4. Okay, this one is B4 and this is BC. Okay, so what about this angle C? If this one is and this one, what is the relation between these two? Alternative angles, right? So alternative angles are equal. That is why they wrote it like this. So we have to write alternative angles. Then we have to write which two lines are parallel. HC is parallel to GBF or GF. Okay, you have to write the reason. That is the question. Okay, so now we know that two angles are equal. Don't forget that one. Okay, maybe we have to use somewhere else. Okay, then next question, 10.2. 1.2. What is that question? B4 is equal to D4. Now you have to say the reason why B4 and D4 are equal. This is B4 and this is D4. That two angles are equal. Yeah, of course, because look at the small circle. Look at that small circle, okay? And this is the line BE, okay? And this is a tangent passing through that point B. This is B4. This is a tangent and this one is BE, okay? So actually this B4 is the angle between this tangent and this chord BE. This chord BE and this tangent, okay? So now look at that from that point B and E, where it is leading. Can you see that D4, it is from these 2 points, that is what you want to check. It is leading to this point D4. Am I right? So if this one and this one, what is the name of that two? Tan chord theorem. That two angles are equal. Am I right? Okay. So what is the reason? Tan chord theorem. Because of tan chord theorem, that two angles are equal. Okay. So that is question number 10.1.2. Now let's move to the next question, 10.2.1. Am I right? 10.2.1. 10.2.1. What is the next question? Prove that triangle DBE is similar to triangle DBE is similar to triangle DBC. Triangle DBC. You have to prove that two triangles are similar. Okay. So how can we prove that two triangles are similar? Where are those two triangles? DBE. So DBE means which triangle is that? DBE. That means this triangle. Am I right, guys? This is DBE. This red one. And next one is DBC. Okay, that big one. Okay. D, B, and now it is C. Did you identify that two triangles? Okay, so now you have to prove that these two triangles are similar. That is the question. Okay, you have to prove that two triangles are similar. So of course that two triangles, here you can see that this B2 plus B3 same angle, am I right? Common angle in both the triangle, red one and green one. B2 plus B3 is there. Okay, so first we can write that one, common one. Okay, so in triangle DBE and triangle DBC, okay, B2 plus B3 is equal to B2 plus B3. What is the reason? It's a common angle. In both the triangles we can see that one is a common angle. This in the small triangle, red one, B2 plus B3 is one angle. In the big triangle, green one, B2 plus B3 is a one angle. Okay, so it's a common angle. Now which one? We already proved that this B4 is equal to C. Previous question, do you remember we wrote the reason? Okay, and also B4 is equal to D4. Okay, so what we proved? B4 is equal to angle C. Okay, it's proven. Or what is the reason we wrote there? B4 is equal to angle C, alternative angles. Okay, we can maybe, if you want, we can write once more. So this one is 1. Okay, first angle. Okay, now we have to prove the second one, alternative angles, which two lines are parallel, or prove one, that is enough. HC is parallel to GF. Okay, then also we proved that B4 is equal to angle D4. Am I right? What we wrote? Tan chord theorem. Do you remember the previous question? Okay, so now look at this one. Angle B4 is equal to angle C and B4 is equal to D4. So what is the meaning of that? It implies that angle C, these two are equal. B4 CA, B4 D4. It means angle C and angle D4 are equal. You understand? Okay, C is or a D4 is this angle. Okay, so let me write it the other way around. It's the same thing, guys. There is no difference, but I just want to write the small one first. D4 is equal to C. Okay, both are the same. C is equal to D4 is the same as D4 is equal to C. Okay, so D4 is one angle on the small circle. Am I right? Okay, let me mark this one. I marked with the one line. Okay, let me mark this one with the two lines. So D4 in the small circle, and C is in the big circle with the two lines. Okay, so this small circle D4 and big circle C are equal. So that is the second one. Am I right? So of course the third one is equal. Third one, that two triangles are, that two angles are equal. What is the reason? Sum of the angles in a triangle. So what is the third one? Here the third small one, third one is this one, E2. Okay, so E2, angle E2 is equal to, then the big circle, which one is the third one? Is it not this combined one? We already took this one and this one. So this one is the combined three angles. Okay, so which one is that? D3 plus D4. Okay, D3 plus D4, that is the third one. What is the reason? Sum of angles in a triangle. So it is enough to prove 2. Then the third one you just write the reason as sum of angles in a triangle. So we already proved that the corresponding angles are equal. So what we can write? Therefore triangle DBE is similar to triangle DBC. Okay, that two triangles are similar. Okay, now here I think, guys, there is a slight mistake in the question. This one is not in order, DBE and DBC. Okay, I will explain on the next question if there is a proportion question. Yeah, next one, there is a proportion question coming. At that time I will explain. Okay, so this one they gave in the question not in the correct order. Okay, anyway, I will explain that one later. Now let's move to the next question. Question number 10.2. Okay, let's move to the next question. 10.2.2. 10.2.2. What is that question? D, you have to prove that D is the midpoint of AB. You have to prove that D is the midpoint of AB. So D is the midpoint of this line AB. Okay. So for that, what we have to do, look at this ratio given. AH is to AG is equal to 1:2. Okay, so AH, let me write that in fraction. AH divided by AG is equal to, so here that ratio is 1:2. That means 1 divided by 2. Okay, so look at that triangle ABG. Look at that triangle ABG. Okay, so here you can see that these two lines are parallel. Can you see that in that triangle? Which one is this? H, D, B, G, and this is A. Okay, so these two lines are parallel. So AH by AG, AH, we already said that this is 1, this is also 1. That is why AG is 2. Do you remember at the beginning of the question I told you? Okay, so AH by AG. So here how can we take AH, that means AD. AD divided by AG. So here it is AB. And what is that ratio? 1:2. Am I right? So that ratio is 1:2. So it means that AD by AB is 1:2. Okay, so it implies that AD by AB, this one, okay, is equal to 1:2. So like what I said, AD by AB is 1:2 means AD is 1 and DB is what? A to B. From A to B it is 2 and this one is 1. So this one is also 1. Just like a previous that side AG. Okay, so it implies that we can directly write AD is equal to DB, because the ratio AD by AB is equal to 1:2 means that AD and DB are, what are the ratios? AD ratio is 1, DB ratio is 1. You understand? Okay, so that is the question. We have to prove that D is the midpoint. So it implies that D is the midpoint. If that two sides are equal, means D is the midpoint of AB. So it means that this line and this line are equal length. Okay. Okay. Now next question, 10.2.3. Question number 10.2.3. 10.2.3. What is that question? Prove that AB square divided by 4 AB square divided by 4 is equal to BC times BE. So what you have to prove? AB square divided by 4 is equal to BC times BE. This is what you want to prove. Okay, AB square divided by BC is equal, AB square divided by 4 is equal to BC times BE. So how can we prove this one? Where is this AB? AB is where this one, BC is this one, and BE is this one. Oh, okay. So can you see that all these ones, BC, BE, that is here, BC is this side and BE is this side, is not connected to that the one that we proved that two triangles are similar. Okay, they took this triangle and this big triangle, the red triangle and the green triangle. Okay, and here one, this AB we can take as a double of DB, because here previous question we already proved that this side AD and DB are equal. So it means that DB, this AB is a double of DB. You understand? Okay. Yeah. Anyway, so we already proved that triangle. Which triangle is that? There you must be careful, guys. Okay. So let me just write it like this because there is a slight mistake in the question. DB, what is given in the question? DB is similar to triangle DBC, but this order is not correct. Okay. Anyway, let's see. So how can we write? Don't follow this order. Now, previous questions I told you, if you have a question like, if you have two triangles are similar, then it is, if it is given like this, then you can follow the order DB by 192, 192, 2 and 3, 2 and 3. Okay, but here in this question, this is not a national paper. Okay, so this question I don't think this order is correct. Anyway, let's see. Okay, so what you have to do, look at the triangle, don't mind about this one, the order. Okay, look at the triangle, from there we can write the answer. First numerator, I am going to write the sides of the small triangle. Numerator, I am going to write the sides of the small triangle, this red one, and denominator, I am going to write the sides of the big one, green one. Okay, so look at the one line one, B2, B3. So what is the opposite side of that one line? Small triangle DE. So DE divided by one line, what is the opposite of the big one? Big side, what is opposite? DC. D by DC is equal to two lines. This is a two line, 1, 2. Okay, what is opposite side of the small one? BE. So it is BE. Two line, big one. This is the two line. What is the opposite side? DB. Am I right? Divided by DB. Three lines, small one, small triangle. This is a three line angle. What is opposite side? BD or DB. Okay, so there also DB divided by three lines, this one of the big triangle. What is opposite side of that angle? It is BC. So divided by BC. So now look at this one. B times BC or BC times B. Can you see that? BC times B here. So I'm going to consider these two proportion. Which two proportion? B divided by DB is equal to DB by BC. Okay. Now can you say what you have to do? Cross multiply. Am I right? Okay. So here DB times DB is DB square is equal to BC times BE. Am I right? Okay. Now DB I told you guys before AD, previous question. AD is to AB. What is the ratio? Or a previous question we already proved that AD is equal to DB. Am I right? Okay. Or D is the midpoint of the. So it means that this AD and DB are equal in length. Okay. So AB and AD are equal in length means look at this one. This is the line A, this is the line point D, and this is the point B. Okay, so AD and BD are equal length means instead of this DB I can write half of AB. Am I right, guys? Because these two are equal length. For example, let's say this is 5 centimeter, this is 5 centimeter. Okay, so DB, that is 5, is equal to half of DB, that is 5. Okay, this is 5. DB is equal to 5 is equal to half of AB. What is the length of AB? 5 plus 5, 10. Can you see half into 10 is 5? Okay, so I can write instead of DB what I can write? Half AB. Okay, so here DB square. What is DB? Half AB. Then square is equal to BC times BE. You understand, guys, that one? Okay, so DB is equal to half of AB. Okay, so now when I expand this one squared is 1 times AB square. So it is AB square divided by 2 square. 2 squared is 4 is equal to BC times B. Is it not that one we want to prove? AB square divided by 4 is equal to BC times B. Okay. So that is question number 10.2.3. Now let's move to the next question, 10.2.4. Let's move to the next question, question number 10.2.4. 10.2.4. And what is there? Prove that, same question, prove that C is to BC. What you want to prove? You have to prove that, what is the question? CE is to BC is equal to 5 is to 9. 5 is to 9. This is what you want to prove. You have to prove that CE is to BC is equal to 5 is to 9, like that. Okay. So now if DB is equal to 3 units and so that is what you want to prove, and there is some conditions given. DB is equal to 3 units. It is given that DB is equal to 3 and what? And BE is equal to 2. BE is equal to 2. So that length also given. DB is 3. This one is 3. Now BE. There is BE. BE. This one is 2. Okay. So that length is also given. Okay. And we have to prove like that. So for that, what we can do here? What about CE? CE, we have to prove that one. Okay, CE is to BC. What is this CE? CE, we don't know anything about CE, but CE we can write it. CE is equal to, maybe we can write it like this: BC minus BE. Am I right, guys? Look at this one. This is the line C, E and B. Okay. So here to find this length CE, it is enough to find BC, this total length minus this length. For example, if the total length is assumed that it is 10 and this length it is assumed that it is 3, then how can I find C? 10 minus 3, that is this and 7. You understand? 10 means total length BC, okay, minus this length, that is 3, okay, so that is B. So CE is equal to BC minus PE. I can write this length CE is equal to the total length BC minus this BE. Okay, so now what is BE? We know that BE is 2. It is given in the question, BE as 2. Okay, so it is BC minus 2. You understand, guys? Because it is given in the question that B is 2. Okay, but I want to know what is BC now. So for that we already proved in the previous question like this, AB square divided by 4 is equal to BC times BE. Am I right, guys? Okay, so from there what is BE? BE is 2. Okay, so it is BC times 2 there. Okay, but I want to know, here I am trying to find BC to substitute here. Okay, so now AB square, how can I find AB now? I'm going in a reverse order now. Okay, so now AB is look at this one, it is given as DB as 3 and we know that AD and DB are equal. So what is this one? That one is also 3. This one is also 3. Am I right? Since DB is given as 3, so it means that this AD is also 3. We already proved that AD and DB are the same thing. Okay, so how can I find this AB? AB is equal to 2 times DB because both are the same length. So it is 2 times DB is given as 3. So it is 6. Can you see that? Okay, so AB is 6. So here AB square, so it is 6 square divided by 4. So when you let me this is first step. So 6 square is 36 divided by 4. Okay, this 2 is multiplication, so this 2 if I take to this side it is division here. Okay, so it is 36 divided by 4 times 2, that is 8, is equal to BC. So 36 divided by 8, what is answer? 36 divided by 8, so it is 4.5. so it means that BC is equal to 4.5. Okay, so do you remember the one that we wrote here? C is equal to B. So this is end. So we are in different steps. Okay, C is equal to BC minus BE. Okay, so now we know what is BC. What is BC? 4.5 minus BE is what? It is given in the question, it is 2. So it is 2.5. So it means that the value of C is 2.5. So now what is BC? 4.5. What is CE? 2.5. So now let's check what is the ratio now. Okay, CE is to BC, therefore CE is to BC. What is CE? CE is 2.5. So it is 2.5 is to BC 4.5. So we want what we want to show? 5 is to 9. So don't forget that this is just a ratio. Okay, so you can multiply both sides with any number. So let's multiply. They want us 5. So just multiply with the 2, multiply with the 2. Okay, so now what is C is to BC? 2.5 times 2 is 5. 4.5 times 2 is 9. So what is the ratio? C is to BC is 5 is to 9. Okay, yeah, little bit tricky one, but you have to practice that. Okay, so that is 10.2.4. okay, now let's move to the next question, 10.3. let's move to the next question. 10.3, question number 10.3. What is that question? Calculate the ratio of area of triangle AHD divided by area of HGB, area of triangle HGB. So which two triangles are that? AHD. Okay, one triangle is this one. Okay, so one triangle is this one. This is one triangle, and the other triangle is which one? HGB. Okay, that's not a completed one. HGB, that is, there is no line like this. Okay, anyway, let's draw a line like this. Okay, we are talking about that triangle. Okay, so what is the second triangle? This one. Okay, and you have to find the area of AHD divided by area of HGB. Okay, you have to find both of that one. So here can you see it is given in the question that these two lines are parallel. So what about this angle and this angle? Corresponding angles are equal. That two angles are equal. Okay, and at the same time, do you remember these two lines are 1:1, or AH is to AG is equal to 1:2 means this is 1 and this is also 1, then only AG is 1 plus 1 2, you remember, or the length of AG and the length of AH are equal, same length. AH and HG are same length. Okay, so anyway, we have to find this one. So for this what we can do is I'm going to apply the trigonometric area rule. Do you remember in trigonometry you studied area is, there is a formula like this, half AB sine capital C. Okay, so those who didn't study, yeah, you must study because this is the last year formula. Okay, so here I'm going to apply this one. Okay, so in that if I consider this one AHD, the first one AHD, this triangle. Okay, so this is A, that one is H, and this one is what? D. This is the point D. Okay, so this is the point D. So I'm going to take these two sides and this angle. Okay, so it is half into, what is this side? H into, this side is HD into sine of, what is the angle? AHD. We have to take this angle. Am I right? These two, then this angle. Okay, sine of AHD. Okay, the whole divided by half into, now which triangle? This triangle. Okay, so which one is that? HGB. Okay, so I'm going to take this angle, so these two sides. Okay, so which one is that? Half into HG into BG into sine of that HGB. Okay, so now we are up to there. Now look at this one here. These AH and HG are same length. Can you see that? AH and HG are same length because of this ratio 1:2. Okay, so it means AG is 2. AG is 2 means that AG is 2, and what is this ratio? AH, it is 1. So to get the full length as 2, if this one is 1, then this one also must be 1. So that is why we can say that AH is equal to HG. Okay, but AH is equal to HG. What is the reason? AH is 2, AG is equal to 1:2. It is given like that in the question. Okay, now also angle AHD, this angle, okay, is equal to HGB. Can you say what is the reason? I already told you at the beginning, these two lines are parallel, so it means that this angle and this angle are corresponding angle. Am I right? So it is corresponding angles. Which two lines are parallel? HD is parallel to GB. Okay. So now if these two angles are equal, it means that sine of that angles are also equal. Am I right? Okay. So now look at this one. AH is equal to HG. These two are equal. That means we can cancel that one. Half we can cancel. Okay. Then AHT and HGB are equal. So sine of that same angles are also equal. Okay. So what is remaining? Therefore, now the remaining is only this HD divided by BG. So what is HD? Where is HD? This length divided by GB. Okay, now what? Oh, okay. Look at that triangle, guys. Look at this triangle. These two lines are parallel. Am I right? Okay. This is our A, H, G, and this one is D, and this is B. Okay. So, and also these two lines are equal, and AD 3A, 3A, that one is also equal. So it means that this H and D are the midpoints of, H is the midpoint of this line and D is the midpoint of this line. Okay, and these two lines are parallel. Have you seen something there? Did you study something, a theorem like that? Midpoint theorem. By midpoint theorem, if these two lines are equal, these one are equal, and these two lines are parallel. What is that one? This GB or this HD is the half of this GB. You remember that one? If this one is 5 centimeter, then this one is 10 centimeter. Midpoint theorem. Okay, so HD is the same as half of GB. Look at this one. This is BG is the same as GB. Okay, let me write this BG as a GB. Okay, BG and GB are the same thing. Am I right? GB. Okay, so here also it is GB. Okay, now HD is the half of GB. So instead of this HD, I can write it as half of GB. What is the reason? Midpoint theorem. Using midpoint theorem, that HD as half of GB. Then the whole divided by another GB. So this GB and GB cancel. So what is the area? Area is equal to half. So area of this one divided by area of this one, the answer is half unit square. Okay. So that is question number 10.3, and that's the end of Northwest September 2020 question paper. I hope all of you understand clearly. Thank you for watching. I know it was a long section, but anyway, we done that one, and I hope you already practiced that one. Okay, so keep on practicing, guys, not only once. Okay, especially this was a good question. There are so many good questions there. Okay, you keep on doing. Okay, first you watch, then try to do alone, then again watch until you can do that one without the help of the video. You try again. Okay, and that's a method to study. It's a hard work. Okay, so anyway, then see you on the next lesson. Thank you.